Microsoft Foundry is not an AI feature. It is an agent factory. And every agent factory becomes shadow IT the moment execution is allowed before governance is enforced. Most AI incidents won't be caused by hallucinations. They'll be caused by agents acting on data no one realized they could see. If you're responsible for identity, compliance, or platform governance, this episode is not optional listening, because the question won't be whether Foundry was allowed, but it will be why no one stopped it. Let me explain why that failure is structurally inevitable and how to block it before your first incident. Reframing Foundry from feature to factory. Reframing Foundry from feature to factory. When most people hear Microsoft Foundry, they see the demo in their head. Model catalog, agents playground, a few connectors to SharePoint or Fabric, maybe a logic app in the background. In other words, a nicer portal on top of Azure AI. Governance hears that and thinks, okay, another tool, we'll add it to the list. That mental model is wrong in a way that matters. Governance thinks, tool. Reality, autonomous workload. Foundry is not where people chat with AI. Foundry is where agents are manufactured and released into your environment. Pause here for a second. Ask yourself, if one of those agents wakes up at night and starts touching data, who do I call? If you don't have a precise answer, you already know why we're having this conversation. From a systems perspective, Foundry assembles 4 things into one execution surface: models, tools, knowledge, and observability. Models provide reasoning. They decide what to do next. Tools are the actuators: logic, apps, functions, APIs, graph. Knowledge is your data: SharePoint, Fabric, vector stores, search. Observability is the trace, if you've invested in it, of what happened. Put those together and you don't get chat, you get behavior. Once an agent is configured, it's not a fancy prompt. It is an identity it runs under, a set of tools it's allowed to call, a memory surface it can read and write, and triggers that start runs. Events, schedules, external calls. That combination is a workload. It can wake up on a timer. It can react to a queue. It can sit behind an API that another system hits. It can chain tools, query a search index, call an internal API, write a record, send a notification. No human in the loop, no user clicking a button, no UI you can point at in a training session. This is the first mental shift I need you to take. Foundry agents are closer to microservices with reasoning than to chatbots with personalities. Developers love that. Can I get the agent to handle this workflow end to end? Your question has to be different. If this thing wakes up at 3 a.m., what is the blast radius and who is on the hook when it crosses it? Governance doesn't fail when agents are created. It fails when execution is allowed before ownership exists. So we've lived this pattern before. SharePoint lists quietly turned into apps without lifecycle. Power Apps quietly wired into production without ALM. Teams bots quietly outlived the projects that justified them. In every case, we started with let people move fast and only introduced real control once entropy was visible. The difference with Foundry is that the unit of entropy is not a form or a flow, it's an autonomous actor. Power Apps failed slowly. Foundry agents fail silently and much faster. If you treat Foundry as an IDE with a pretty UI, you'll set some quotas, maybe a DLP rule for uploads, and you'll feel like you did something. Meanwhile, the real risk surface sits in the control plane you didn't define. Who can create agents? Under which identities? With which data boundaries? And with what level of observability as a precondition to execution? Most orgs today treat labels as metadata. What you need are labels as execution constraints. That means an unlabeled dataset is not work in progress. It is ineligible for autonomous access. It does not exist as far as agents are concerned. It also means an unowned agent identity is not temporary. It is not allowed to run, ever. We'll go deep on those mechanics later. For now, I want you to hold one framing. Foundry is a platform as a service for agentic workloads. Each agent is a non-human identity with tools and data attached, capable of acting at cloud scale. Every time one of those identities executes without a clearly enforced owner, a clearly enforced data boundary, and a clearly enforced audit trail, you didn't automate a task, you automated risk. And that is what turns an impressive demo into the next generation of Shadow IT. Historical pattern, how Microsoft platforms created Shadow IT. Historical pattern, how Microsoft platforms created Shadow IT. Let me ground this in something you've already survived. This isn't the first time Microsoft gave the business a powerful surface and let governance show up later. The labels have changed. The failure pattern has not. Start with SharePoint. Officially, SharePoint was collaboration, document management, team sites. In reality, it became an application platform for people who'd never heard the word platform. Lists became databases, views became UIs, a couple of calculated columns and content types. Later, you had a critical business app running in a team site no one in IT could find. What was the governance failure there? SharePoint's problem wasn't that people built things. The problem was that nothing in the product or the process defined a lifecycle. No one had to declare, this list is now a system of record, this site has an owner, this workflow must be retired when the project ends. So 10 years later, you had thousands of lists, hundreds of apps, And permissions no one could reconstruct. Every attempt to clean up felt like defusing a bomb with no diagram. Then came Power Apps and Power Automate. The pitch shifted from collaboration to citizen development. Build apps, wire flows, automate processes, no code. And the business did exactly that. They connected low-code apps into finance, HR, CRM line of business systems. Flows moved data between SaaS platforms, updated records, sent emails, created tickets. Again, the central governance failure was clear: no ownership. Environments and DLP policies arrived after there were already hundreds or thousands of apps and flows in the wild. Many were created by people who had since moved roles or left the organization. There was no enforced concept of this app has a business owner, this flow has a life cycle, this identity is responsible. So security and compliance teams had to start by discovering what even existed. Then they had to negotiate with business owners who had accidentally built production dependencies on fragile, undocumented automations. You'll recognize the pattern: innovation first, governance as archaeology, then teams moved in as the new operating system of daily work. Suddenly you had apps and bots living in the same surface where people chatted all day. Tabs pointing to external systems. Bots with graph scopes broad enough to see and do almost anything. Messaging extensions calling into services no one had ever security reviewed. On paper, governance controls existed. App permission policies, tenant app catalogs, admin approval workflows. In practice, those controls matured only after adoption was already massive. So teams replayed the same movie with a slightly different script. The governance failure here was decommissioning. Apps and bots were introduced for projects, pilots, one-off experiments. But almost no one had a muscle for deliberate shutdown. We knew how to approve something once. We did not know how to say, this bot must die on this date unless someone renews its existence. SharePoint, no lifecycle. Power Apps, no ownership. Teams, no decommissioning. 3 waves, same story. Execution embedded into collaboration surfaces without a control plane that defined who owns this, how long is it allowed to exist, and what has to be true for it to stop. Now connect that history to Foundry. In all 3 previous waves, the unit of risk was still, in some weak way, human-triggered. Someone had to click a list item. Someone had to open a Power App. Someone had to talk to a bot in a channel. That gave you at least one thin handle. There was a UI, a button, a chat. You could ask, who uses this? You could see the surface where the behavior emerged. Foundry removes that last bit of friction. Foundry agents don't need a user session. They don't wait for someone to click. They wake up on schedules. They react to events. They sit behind APIs. They can be chained by other services you don't even control. So if you repeat the same governance pattern, adoption first, controls later, you don't just get more shadow IT. You get autonomous shadow IT. You get agents that keep operating when the project is over, when the sponsor has moved on, when the person who wired the permissions has forgotten what they granted. And because there is no UI to stumble across, you don't discover them by accident. You discover them when an auditor asks why a summary contained data from 3 systems you swore were segregated. That's why I'm spending time on the historical curve. It's not nostalgia, it's a prediction. If you let Foundry follow the SharePoint, Power Apps, and Teams trajectory, you will end up in the same place, just faster, and with actors that don't wait for humans before they act. The platforms changed. The pattern didn't. The only new variable this time is autonomy. And autonomy is what turns familiar governance gaps into incidents you can't explain in the room where it matters. Failure mode 1, agent identity collapse. Now I want to walk through the first failure mode because it's the one that quietly turns every other control into theater. This is failure mode 1, agent identity collapse. I call it agent identity collapse because at a high level it sounds simple. The agent keeps acting when the human it was anchored to no longer exists in the way your governance model assumes. But the operational reality is uglier than that. Identity collapse is the moment where everyone in the room knows something is wrong, and no one knows who is allowed to turn it off. This is where most governance models quietly break, because they never encoded who owns a non-human identity when the humans move on. Here's the archetype. A project team stands up a Foundry agent. They're under pressure. There's an exec sponsor. There's a demo date. So they do what every team under pressure does. They reuse whatever identity path is easiest. Maybe they wire the agent to run under a user's delegated context. Maybe they attach it to a generic automation account that already has broad rights. Maybe they grab an existing service principal because it's just a pilot. In week 1, that feels harmless. Everyone in the room knows what the agent does. The sponsor is excited. The project lead can point to the Entra object and say, yes, that's ours. From a pure authentication standpoint, it even looks clean. The agent can get a token, conditional access passes, logs show a known identity making calls, then time happens. 6 months later, the sponsor has moved on. The project lead has changed teams. The contractor who actually wired the identity is long gone. The user account that originally granted consent is disabled. The distribution list you thought was the owner no longer maps to a real group of people. but the agent is still running. Tickets are still being triaged. Records are still being updated. Emails are still being sent. Nothing in Entra is technically broken. The token is valid. The app registration still exists. The automation account is still in the right groups. From the system's perspective, everything is fine. From a governance perspective, identity has collapsed. The execution continues. The ownership has evaporated. This is the gap between authentication and accountability. Authentication tells you the caller had valid credentials. Authorization tells you the permissions attached to that identity allowed the action. Neither tells you whether any living human still intends for that identity to exist. If an agent can execute without an owner, you didn't automate a task, you automated risk. Pause on that, because it defines your entire agent control plane. Let me make this concrete. Incident A looks like this. A Foundry agent is built to triage support tickets. It reads from a queue, pulls customer details from Dataverse, looks up documentation in a SharePoint site, and writes a summary back into a system of record. To move fast, the team has it run on behalf of a shared automation account that already has the right graph scopes and data access. No one wants to wait for a new access request. They tell themselves they'll clean it up after the pilot. The pilot works. People are happy. Time passes. 18 months later, a different team needs to fix an unrelated problem and gives that same automation account access to a new data source, maybe HR data, maybe finance. No one in that meeting remembers there is a Foundry agent silently executing under that identity. Now, your ticket triage agent, designed for one narrow workflow, is operating with a much larger blast radius, touching data it was never modeled for, under an identity no one feels they own. Nothing left the tenant. There was no external compromise. Every call in the logs is legitimate. Try explaining that to an auditor. This is what I mean by agent identity collapse. The system can prove the agent was allowed to act. Nobody can prove that anyone still intends for it to have that power. And this isn't limited to bad hygiene. It's structural whenever you treat agents as side effects of other identities. User accounts, shared service principles, catch-all automation apps. Agents need to be first-class security principles, not users, not borrowed service principles. Distinct non-human identities with 4 mandatory attributes: an owner, a purpose, a maximum lifetime, and a decommission trigger. That's the minimum shape of a non-human identity in a serious agent control plane. If you can't answer those 4 for a given agent, you are already in identity collapse territory. You just haven't seen the incident yet. This is also where people lull themselves with the idea that we log everything. Yes, you should log. Yes, you should integrate with your SIEM, but logging an orphaned identity faster does not fix the fact it's orphaned. If your access model depends on remembering why a permission exists, it has already failed. The only durable pattern is identity-driven agent control. Unique workload identities for agents, created through a governed pipeline, tagged with owner and purpose, reviewed on a schedule, disabled when the trigger condition hits. No exceptions, no just for this demo. No will refactor later. Because later is always when the person who understood the shortcut has already left, and the agent they wired is still acting as if nothing changed. If you simplify failure mode 1, it comes down to this. Once autonomous execution survives longer than human ownership, your pre-execution governance is already gone. Failure mode 2, permission drift in agent access. Identity collapse is what keeps an agent alive after ownership dies. Permission drift is what quietly expands what that agent can touch while nobody is looking. If identity collapse answers, who is this? Permission drift answers, what can it do? And that answer keeps changing. This is failure mode 2, permission drift in agent access. The pattern is depressingly consistent. Incident B starts clean. A team builds their first Foundry agent with a tight access model. They do almost everything right. They create a dedicated workload identity. They granted read access to one SharePoint site, read access to one shared mailbox, write access to a single logging store. They document it. Security signs off. Everyone feels like this is how it's supposed to work. Then the second agent arrives. It has a similar but not identical job. Maybe it needs to read 2 sites instead of 1. Maybe it also has to update a ticketing system. Under pressure, the team does the most natural thing in the world. They reuse what already works. They hang the new agent off the same identity or the same role assignment, and they just add a couple of extra permissions. You've just merged 2 logical workloads into one permission surface. One agent has no legitimate reason to touch system B. The other has no reason to touch system A, but they now share an identity that can do both. Then the third agent shows up. This one belongs to a different team entirely, but the platform folks remember that the existing identity already has almost everything it needs. There is one missing permission, a write scope on a new data source. Someone grants a temporary exception. There is a verbal understanding that this will be fixed properly once the pilot proves its value. 30 days later, the pilot is production by usage, not by design. No one has revisited the identity. Now you have a single non-human principle that can read from 5 different sources, write to 3 more, and nobody can cleanly explain why. That is permission drift. It's not one catastrophic decision. It's a series of small, reasonable exceptions that aggregate into an access graph no one ever intended. And with agents, that drift is amplified by how invisible the execution is. In traditional app governance, you at least have a UI to grab onto. There is an app tile, a URL, a mobile client. You can say, show me everything attached to this thing. With Foundry agents, there may be no UI at all. The execution surface is a queue, a scheduler, or an API endpoint buried inside another system. So by the time someone asks, which agents can touch this HR dataset, your honest starting point is, we know which identities can. We're less sure which agents are hanging off them. This is also where non-human identities turn drift into a multiplier. Service principals and managed identities are designed for reuse. That's their power and their danger. In a microservice architecture with strong discipline, you might have one identity per service boundary. In early stage agent adoption, the temptation is always the opposite. Hang more agents off the same automation identity because it already works. If your process doesn't fight that instinct, drift is guaranteed. If your access model depends on remembering why a permission exists, it has already failed. And the most insidious part is that nothing looks wrong in the logs. Every call is properly authenticated. Every token carries the right roles. There is no explicit deny being violated. Your CMC's normal operations. From the system's point of view, everything is compliant. From a governance point of view, the boundary has already moved. Now layer in the fact that Foundry agents are not deterministic flows. A Power Automate flow has a fixed sequence. You can read the steps in order and understand the path. An agent chooses tools at runtime based on instructions and intermediate results. It can chain calls, retry, pick alternate paths. So when its underlying identity gains access to a new data source, that new path is not just theoretically available. It is available to a reasoning system that is incentivized to explore. That's how you end up with an agent that was originally scoped to read from this support mailbox and this documentation site, suddenly able to pull internal HR notes because the shared identity picked up a broader graph scope, join that with customer emails, and write a holistic view into a system no one expected to contain that combination. Again, nothing left the tenant. No firewall was breached. Every permission was granted by someone for some reason at some point. Try diagramming that story in a risk committee. If your access posture for agents is, we'll just be careful when we add permissions, you've already lost. Monitoring is not governance. Monitoring is not governance. The only durable way to contain permission drift is to design for it upfront. Every agent gets its own minimum necessary access profile, expressed as narrowly as your platform allows, bound to its own non-human identity. No shared service principles. No omnibus automation roles. Yes, that sounds slower on day one. But permission models are like concrete, easy to pour, incredibly hard to reshape once it sets. Optimizing for speed over reversibility is how you end up here. An estate full of agents no one wants to touch because no one can predict what else each identity might be enabling. And remember, monitoring doesn't fix drift. It just tells you faster that it already happened. If the only thing standing between your agents and a wider blast radius is the hope that people will remember why a permission was added, you don't have governance. You have a story you tell yourself until the next incident. If you simplify failure mode 2, it comes down to one thing. A single overprivileged identity turns a clean design into shadow AI you can't reason about. Failure mode 3. Data boundary collapse. Identity collapse keeps the agent alive. Permission drift grows what it can touch. Data boundary collapse is where on paper everything looks compliant and you still end up with a reportable incident. This is failure mode 3. Data boundary collapse under autonomous execution. Here's the archetype. Incident C starts out as a model of good behavior. A team builds a Foundry agent to help a support function. The design looks sane. The agent reads from a shared support mailbox in exchange, pulls related documentation from a specific SharePoint site, calls an approved external API for status, drafts an internal update in a ticketing system. Each individual access goes through the right channel. Exchange admins see a workload identity reading a scoped mailbox. SharePoint admins see a trusted app with rights on one site collection. Network security sees outbound traffic to an allow-listed third-party endpoint. The ticketing team sees an internal integration account updating records. Every control surface sees its own piece and says, yes, this is fine. No one sees the full path. What the agent is actually doing is stitching those hops into one flow, reading potentially sensitive customer content from email, correlating it with internal docs, enriching it with third-party data, and then writing a synthesized view somewhere else. If your purview policies, your DLP rules, and your network controls are all scoped to one system at a time, they will happily bless each leg of that journey. That's data boundary collapse. Every hop is individually compliant. The combined execution crosses a line your policies assumed would hold. Let me restate this because it's easy to miss how dangerous that is. Nothing was leaked, nothing left the tenant, and the policy was still violated. You see this most clearly once you add retrieval augmented generation and tool orchestration. A typical Foundry agent can Query a vector store built from labeled SharePoint content, search email via graph, call a line of business API that returns semi-structured records, and write outputs into another system. Each tool has its own security story. Each dataset has its own label strategy. Each admin team feels they've done their job. What you almost never have is a control that evaluates the combination. No one is asking, in a machine-enforceable way, is it acceptable for an autonomous agent to combine data from these three label classes and push the result into this fourth system without a human validating the path in the middle? Traditional purview DLP is very good at obvious exfiltration patterns, emailing a highly confidential document to an external domain, mass downloading regulated data to an unmanaged device, uploading sensitive files to an unsanctioned SaaS app. It is much weaker when the data never leaves approved systems but crosses an implicit policy boundary. For example, you may have a rule of thumb that HR notes stay in HR systems, customer PII stays in support systems, financial details stay in finance. Individually, those systems are locked down. But your agent, operating as a reasoning layer above all three, can be instructed or can infer that to produce a 360-degree view, it should pull HR performance notes, support ticket history and billing status, and merge them into a single narrative. No single system knows that happened. Each only sees its own queries. Your DLP rules don't fire. Your export controls stay quiet. Your firewalls are happy. From a logging perspective, nothing illegal occurred. From a regulatory perspective, you may have just combined classes of data in a way your own policies explicitly forbid. That's the heart of data boundary collapse. The agent becomes an invisible integration surface that tunnels through the spaces between your controls. If you simplify failure mode 3, it comes down to this. Every system thinks it is enforcing policy, but no one governs the combination an autonomous agent can assemble. Hold that thought, because this is where your agent control plane either exists or it doesn't. And agents don't interact with labeled content the way humans do. Sensitivity labels were designed around human actions: open, edit, share, send. Agents often see chunks from a vector index, tokenized snippets from search, aggregates from APIs. Those fragments may never carry a visible label into the execution context, even though they originated from highly labeled sources. So you can end up in a place where every original document is correctly labeled, every mailbox is correctly governed, every API is properly scoped, and the agent's working memory, a blend of snippets, embeddings, and intermediate summaries, sits entirely outside your labeling model. If you don't anchor agent behavior to predefined enforceable label combinations, it will happily synthesize across boundaries you never meant to be porous. Saying our data is labeled is not enough. You need a policy that says, in effect, for autonomous agents, these label classes may be read together, these may be written together, and these combinations are simply not allowed. And that policy has to be enforced before the agent exists, not inspected after the first bad summary goes out. That's pre-execution governance applied to data, not just identity. Because once the agent is live, it will explore the space you gave it. It won't ask whether your policy assumed those systems would never meet, or why Foundry agents are worse than low-code apps. At this point, you might be thinking, we've seen this before with Power Apps and Power Automate. We survived that. How much worse can Foundry really be? The uncomfortable answer is structurally worse. Not because the technology is malicious, but because the execution model removes the last accidental safety rails low-code gave you. Power Apps, Power Automate, even most Teams apps share three properties that made governance late but still possible. They are user-triggered, they are UI-bound, and they are, at least in theory, easy to inventory. A Power App needs someone to launch it. A flow usually fires off something a human did, submitting a form, updating a row. Even scheduled flows have a visible artifact in an environment you can list. You can go into the Power Platform Admin Center, pull a report of apps and flows, sort by owner or environment, and you at least have something concrete to start a conversation around. Low-code governance assumes determinism. You have a definition of the flow. You have a person who clicks. You have a surface you can point to and say, this is the thing we're talking about. Agents operate on probability and context. That's why you cannot recycle your low-code playbook and expect it to govern autonomous execution. Foundry takes away all three crutches. First, user-triggered versus autonomous. Foundry agents are workloads. Once deployed, they wake up on events, timers, webhooks, or calls from other systems. There may never be a human in the loop for a particular run. There may never be a UI at all. The risk doesn't live where someone clicks. It lives where events fire. Second, UI-bound versus invisible. When a Power App breaks, a user sees it. A form doesn't load. A button doesn't work. That pain is often how security discovers something exists. When a Foundry agent misbehaves, it can do so for weeks before anyone notices, because there is no daily human touchpoint. Maybe its output is another system's input. Maybe it feeds a weekly report someone glances at between meetings. You lose that thin lifeline of the thing people complain about. Third, easy inventory versus dynamic execution graphs. You can inventory low-code apps by environment. You can see which connectors they use. You can map, with some effort, this app talks to this data. An agent's execution path is not a static diagram, it is a reasoning process. At runtime, it chooses tools based on intermediate results and instructions. Two runs of the same agent can hit different tools, different data, different destinations. So the idea that you'll document the flow once and review it annually simply doesn't hold. And this is before we talk about sprawl. Low-code sprawl gave you shadow IT with forms and flows. Annoying, risky, often bounded by human attention. Foundry gives you shadow IT with autonomous actors. Agents that execute under non-human identities can call any tool that identity can reach, can be triggered by systems no one in IT even administers, and can change their own behavior as new tools are wired in. Most AI incidents won't be caused by hallucinations. They'll be caused by agents acting on data no one realized they could see. This is where the old governance reflex will monitor it collides with reality. Monitoring is not governance. If your first response is, we'll watch it, the decision is already made. You've accepted that ungoverned execution will shape your environment, and you're just hoping to notice before it hurts. With Power Apps, that posture was barely tolerable. With Foundry agents, it's an admission that you're willing to let autonomous systems operate in production without a control plane. And there's one more difference that matters: how easily capability expands. In a low-code app, adding a new connector is a deployment event. You change the app, there's a PR, a solution export, at least some visible step. In an agent, adding a new tool is often an infrastructure decision. You publish another internal API. You light up a new vector store. You broaden a role on a managed identity. Suddenly, every agent hanging off that identity has a new potential path without anyone touching the agent definition. You didn't tell the agent, you can now read the system. You told the identity, you can now read the system. The agent discovers it at runtime, so your effective behavior surface grows with every convenience change you make to the underlying access model. Power Apps failed slowly. Foundry agents fail silently and much faster. If you try to reuse your low-code governance muscle, inventory, quarterly reviews, owners in a spreadsheet, against a system that is probabilistic, autonomous, and API-driven, it will look like it's working right up until the first incident. In other words, the old model governs app tiles and flows. It does not govern an agent control plane. And when that incident hits, the story will sound familiar. There was no breach, no external attacker, no policy explicitly broken at any single hop. And yet an agent combined data in a way your own rules said it never should. The difference is that with Power Apps, you could at least point to a screen and say, that's the thing that did it. With Foundry, you'll be pointing at an execution trace and an orphaned identity, trying to explain to people who don't live in Entra why allowed and intended were never the same thing. Designing an agent control plane, identity as the first boundary. By now, the pattern should be obvious. If you let agents exist before you define how they are identified and contained, everything downstream turns into guesswork. So the first boundary in an agent control plane is not data, it's identity. And I don't mean we have an app registration in Entra, so we're fine. I mean, every agent is treated as a first-class security principle with an explicit lifecycle, clear ownership, and a constrained field of operation. If you're serious about this, there are 4 questions you must be able to answer in writing for every production agent. Who owns it? What is it for? How long is it allowed to exist? What event forces it to shut down? If you can't answer those 4, you don't have an agent, you have a ghost. In Entra terms, you really only have 3 patterns available for agents: user impersonation, generic service principles, and dedicated workload identities. Only one of those belongs anywhere near production: dedicated workload identities for agents. User impersonation, on behalf of flows, sounds attractive because it keeps access personalized. In practice, it destroys accountability. When something goes wrong, your logs say the user did it. Good luck explaining which actions were consciously taken by a human and which were silently executed by an agent in their name. Generic service principles are worse. They become the organizational junk drawer. Every time you reuse one, you deepen permission drift and hide more execution behind a single opaque identity. Agents need their own identities, a unique Entra object per agent, or at most per tightly related agent family, tagged with an owner team, a business purpose, an environment, and an expiry date. No owner, no execution, no purpose, no execution, no expiry, no execution. That's the baseline. This is where identity-driven agent control starts. You also have to separate how the agent proves who it is from what it's allowed to do. Authentication tells you this is the agent. Authorization tells you here is the slice of the world it can touch. Those must be independently governed. On the authentication side, anything that depends on a static secret is a liability. If you have an agent whose entire existence depends on a client secret sitting in a config file or a key vault that no one rotates, you've just created a long-lived backdoor with no natural kill switch. Agents should authenticate using modern, secretless patterns, managed identities, workload identity federation, token exchange, Credentials, the platform issues and rotates, not strings a developer copied from a portal 6 months ago. On the authorization side, this is where conditional access for non-human identities stops being optional. Most orgs think of conditional access as the thing that enforces MFA for users. You need the agent version of that discipline. Policies that say explicitly, these identities may only sign in from our Foundry runtime. These identities may only access these resource types. These identities are blocked from specific high-risk operations, regardless of token contents. You're not going to prompt an agent for MFA, but you can absolutely gate it on context. Is this coming from the expected workload? Is it using the correct identity? Is it trying to reach a resource class it was never cleared for? If the answer doesn't line up with policy, the token shouldn't be honored. Full stop. Then there's impersonation. Agents that act on behalf of users should be the exception you escalate, not the default you casually allow. If you must let an agent impersonate a user, scope it like a scalpel. This agent, this user population, these operations, this system, this time window, everything else stays under its own workload identity with its own clearly defined permissions. And none of this matters if you don't wire in lifecycle. Agent identities should not be created by hand in the portal at 11 p.m. before a demo. They should be provisioned through a pipeline that enforces naming, tagging, and baseline policies. Scripted at minimum. Policy as code if you're serious. Deprovisioning needs the same rigor. When a project ends, when an owner changes roles, when the maximum lifetime hits, the identity should be flagged automatically. Someone has to consciously renew it with justification or let it die. No identity should be immortal by default. So your week 1 control plane for identity looks like this. Inventory every non-human identity any agent could be using. Flag the ones with no clear owner. Flag the ones with broad rights. Prohibit new agents from binding to them. Then define a single hard rule. No dedicated workload identity, no agent. No owner tag, no agent. No expiry, no agent. Because until you can look at an Entra object and say that is an agent, here is who owns it, here is what it can do, here is when it dies, you don't have a control plane. You have a factory full of unlabeled machines all wired to the same power bus and no breakers you trust enough to flip. And when the first incident hits, that's exactly what it will feel like. The refrain, on purpose. Identity is the first boundary. By now the pattern should be obvious. If you let agents exist before you decide who they are and how they're contained, everything after that is guesswork. Say it out loud. Identity first, data later. Everything else is detail. This is the intentional repetition, not a copy, a reinforcement. Most orgs try to start with data. They shouldn't. The first boundary in an agent control plane is not data, it is identity. And we created an app registration in Entra is not identity. Identity means the agent is a first-class security principle with a lifecycle, a custodian, and a fence line you can draw on a whiteboard. Think of 4 properties you can't compromise. A steward, the accountable team on the hook when it moves. A charter, the exact problem space it is allowed to operate in. A clock, an expiration that forces renewal or retirement. A kill switch, a condition that shuts it off without debate. If you can't state those 4 in writing for a single agent, you don't have a workload. You have a ghost. No owner, no execution, no owner, no execution. This is not ceremony. It's how you prevent a non-human identity from outliving the intent that justified it. Let's zoom in and vary the angles, because this is where orgs convince themselves they're fine. 3 ways agents show up in Entra. As user impersonation, on behalf of. As a borrowed service principle, automation app. As a dedicated workload identity. Only one is defensible at scale. User impersonation keeps access personalized, then removes accountability. When something goes wrong, the logs say the user did it. You will spend weeks separating human action from agent action that happened under that user's name. Shared service principles are worse. They become a junk drawer for exceptions. Every reuse deepens permission drift and hides behavior behind a single opaque actor no one owns. Dedicated workload identities are the only adult option. One agent, one principal, one perimeter. Tag them like you mean it. Steward team, not a person. Business charter, 1 sentence, specific. Environment, dev for test, prod, expiry, a real date, not never. No purpose, no execution. No expiry, no execution. That is the baseline. Now separate 2 ideas you must never conflate. Authentication proves this is the agent. Authorization answers here is the slice of the world it can touch. Those are independent levers, govern them separately. On authentication, if a static secret can keep an agent alive, you've built a backdoor with no natural end. Dump client secrets. Prefer secretless patterns, managed identities, workload, identity federation, token exchange. Credentials the platform issues and rotates, not strings somebody pasted into a config the night before a demo. On authorization, conditional access for non-human identities is not optional. You're not going to prompt an agent for MFA, but you can enforce context, only sign in from your Foundry runtime, only call the resources you were cleared for. Block entire classes of operations regardless of roles in the token. If the context doesn't match policy, the token is not honored. Full stop. About impersonation, make it the exception you escalate, not the default you encourage. And when you approve it, narrow it to a scalpel. This agent, this user population, these operations, this system, this time window, everything else runs under its own workload identity with least privilege. Lifecycle is where most programs quietly give up. Don't provision identities through a pipeline that enforces naming, tagging, and baseline policy. Scripted bare minimum. Policy as code. If you're serious, deprovision with the same rigor. When the clock hits, the steward renews with justification or the identity dies. No immortal accounts, no sentimental exceptions. Inventory is not optional theater. It's how you find the ghosts you already have. Week 1 discipline. Enumerate every non-human identity agents could be using. Flag the orphans, no steward tag. Flag the giants, broad rights. Ban new agents from binding to either. Then set the single hard rule that actually moves behavior. No dedicated workload identity, no agent. No steward tag, no agent. No expiry, no agent. Here's a fresh scenario to make this less abstract. A product org ships a renewals assistant. Clean design, clean runbook. Dedicated identity, owner tag, read-only scopes across a labeled set of customer assets. Sales loves it. Quarter later, Ops adds a small enhancement. Give that same principal write access to a scheduling system, just for convenience. No one circles back to the identity record. The steward team doesn't formally accept the change. A quarter after that, finance asks why renewal reminders now include meeting details and internal notes that were never supposed to leave the sales system. No breach, no exfiltration. Every API call was legitimate. The agent simply discovered, at runtime, the widened perimeter on its identity and behaved accordingly. Could that have happened with a named steward, a charter that forbids cross-system writebacks, a clock that forces renewal, and a kill switch tied to scope changes? Unlikely. Without them, inevitable. Identity is not a checkbox. It's the breaker you trust enough to flip when the trace looks wrong. And the refrain matters because it anchors the next gate. Identity gives you a named actor. Permissions define what that actor can touch in theory. Neither answers the question that burns your time in incident review. What combinations of data was this thing ever allowed to assemble? That's the next boundary, data, sensitivity labels and DLP, and they only work if identity came first. But hold the line here. One agent, one principal. One owner on record. One charter with teeth. One clock, that forces a choice. One kill switch wired to policy. Because if an agent can execute without those, you didn't automate work. You automated risk. And you will read about it later, written by someone else to an audience that wasn't in your design review. No owner, no execution, no label, no agent, no audit path, no production. Identity first, always. Execution visibility, observability, and agent data access auditing. Identity tells you who the agent is. Labels tell you what it's allowed to assemble. Execution visibility is how you prove what actually happened. Without that third pillar, you are still guessing. You're just guessing with better vocabulary. When people say, we'll monitor it, what they usually mean is logs exist somewhere. For agents, that's not enough. You don't need a pile of events. You need a narrative. For any run that matters, you should be able to answer 5 questions without launching an incident war room. Which agent executed? Under which identity? Which tools did it call in what order? Which labeled data did it read or write along the way? What decision points changed its path? If you can't reconstruct that story, you can't audit behavior, you can't prove compliance, and you definitely can't walk into an investigation with anything stronger than opinion. So let's make this concrete. At minimum, observability for agents has to capture 4 dimensions. First, agent context. Every run needs an immutable identifier for the agent definition, the version, the environment, and the workload identity. Not some call from Foundry. This specific agent, version N, in environment X, acting as identity Y. Second, the tool graph. You need a trace of which tools were invoked, in what sequence, with which inputs and outputs at a metadata level. I don't mean storing full payloads forever. I mean enough structure to say, this run queried a vector store built from content labeled internal confidential, searched an Exchange mailbox labeled customer PII, called an API that returns finance restricted records, then wrote into a system labeled operational internal. That's an execution graph. Without it, you're just staring at individual log lines. Third, the data access footprint. This is where your purview integration stops being theoretical. For each tool call, you want to know which labels were present on the resources touched. Were those labels allowed under this agent's declared policy? If an agent that was only approved for internal suddenly reads from highly confidential, that shouldn't hide as a generic API request. It should surface as a boundary violation in your traces. Fourth, decision points. Agents don't just march through a static flow, they choose. You don't need to log every token of model reasoning, but you do need markers where the agent changed course. It retried a tool, it chose an alternate tool, it declined to act because a precondition failed, it escalated to a fallback path. Those are the moments an auditor or an internal review will care about. Why did it go left instead of right? If your traces flatten everything into API calls, you've lost the why. This is where something like OpenTelemetry becomes useful, not because you care about the standard itself, but because you need structured, correlated traces. Think of each agent run as a trace, each tool call as a span, labels and policy decisions as attributes and events. That gives you the raw material for two critical capabilities, runtime alerting and forensic reconstruction. Runtime alerting is obvious. If an agent crosses a label boundary it was never approved for, or starts calling tools outside its declared set, you want a signal now, not in an annual review. But forensic reconstruction is where most organizations quietly fail. When someone says this summary contained HR details that should never have left HR, you need to pull that run and walk through it. Here is the agent, here is the identity, here are the tools it called, here are the labels it touched at each step, here is the decision where it chose to include that fragment. If your only answer is, well, the agent has access to those systems, you've already lost the argument. Agent data access auditing sits on top of this observability fabric. It's not a separate log. It's a set of questions you know you'll need to answer, baked into how you design traces. Questions like, show me all runs of any agent that read data labeled regulated and then wrote to destinations labeled external. Show me every run where HR confidential and finance restricted appeared in the same trace. Show me executions under identities that were flagged for review or should have been decommissioned. If those queries take a week of log wrangling, you don't have auditing. You have a data lake. And here's the hard truth. Observability without control is theater. If your traces can show you that an agent is misbehaving, but you have no reliable kill switch, no way to revoke its identity, no way to block its label access before the next run, all you've built is a very expensive rearview mirror. Execution visibility has to be wired back into the control plane. That means a central switch to disable an agent identity instantly, a mechanism to block an agent's access to specific labels or tools based on what your traces reveal, and one non-negotiable policy: if an agent cannot meet your observability and auditing requirements, it does not run in production. No exceptions, no temporary blind spots. No, we'll add tracing later. Because in the room that matters after the incident, you will not be judged on how many logs you collected. You'll be judged on whether you can say, clearly, here is what the agent did. Here is why it was allowed to do it. Here is how we made sure it can't ever do it again. The non-negotiable rule, pre-execution governance only. Everything I've walked through so far points to one conclusion. This is the non-negotiable rule of your agent control plane. If you let agents execute before governance is enforced, you have already lost. Not you might have a problem later. Not you should keep an eye on it. You have accepted that your environment will be shaped by autonomous behavior you do not control. Anything else is theater. Everything after this is damage control. So I want to state the rule plainly, so there is no wiggle room. If an agent can execute before identity, data boundary, and observability are in place, governance has already failed. Pre-execution only. Pre-execution governance is the only governance agents will ever truly respect. When you apply controls after agents exist, you are doing theater. You can add purview policies, you can tighten conditional access, you can enhance logging. But all of that is happening in an estate whose shape was already determined by ungoverned execution. You're not building an agent control plane. You're trying to decorate one that autonomous execution has already drawn for you. You are bolting guardrails onto systems that were never designed to carry them. That is exactly what happened with SharePoint, Power Apps, and Teams. Governance arrived after the fact. It reduced some risks. It never erased the entropy. With Foundry agents, that same posture is worse than ineffective. It actively hides the real state of your environment behind dashboards and reports that look mature. A post-creation policy is opt-in by definition. It assumes everything that existed before the policy is either exempt or will be discovered and remediated by hand. In practice, that means your oldest, riskiest, least documented agents are precisely the ones least likely to be constrained. If your AI strategy starts with "will monitor it," you've already accepted the outcome. Monitoring is a feedback loop. Governance is a predicate. Feedback loops improve a system that already exists. Predicates decide which systems are allowed to exist. So what does pre-execution governance actually look like for Foundry? It looks like gates, hard ones, wired into the only path that leads to production. For agents, there are 3 gates that matter. Gate 1 is identity. If there is no dedicated workload identity, tagged with an owner, a purpose, an environment, and an expiry, deployment fails. Not raises a warning, fails. No owner, no execution. Gate 2 is data boundary. If the agent's declared tools and knowledge sources cannot be mapped via purview to an approved combination of sensitivity labels and destinations, deployment fails. No label, no agent. That's the line. You don't let agents run over unlabeled data. You don't trust hand-wavy assurances that the system is internal. If purview can't classify it, Foundry can't touch it. Gate 3 is observability. If the agent cannot produce traces that meet your auditing requirements, identity, tool graph, label footprint, decision markers, it does not run in production. No audit path, no execution. Those 3 gates, identity, boundary, visibility, are the minimal pre-execution requirements. anything less and you are not governing agents, you are annotating them. You might be thinking, we can't afford to be that strict in week one, we'll block innovation. The reality is the opposite. Pre-execution controls create a predictable surface for innovation. Developers know the rules. If they define identities correctly, choose labeled data sources, and adopt the observability template, their agents ship. If they cut corners, they don't. That is infinitely more empowering than the world you're in now, where teams build whatever they like, only to have security show up months later with a list of violations and a vague threat to turn things off. It also aligns with where regulation is going. Most of the upcoming AI compliance requirements, EU AI Act sector guidance, internal audit trends are converging on the same question. Show me how you decided the system was safe before you deployed it. Pre-execution gates give you that story. You can point to the identity policy. You can point to the purview evaluation. You can point to the observability checklist. You can say, nothing reaches production without passing these controls. And that's the hinge. Either you decide now that no agent in your estate is allowed to run without passing those gates, or you wait, let the factory spin up and discover your real architecture in an incident report written by somebody else. Every agent you allow today defines the incident report you'll read tomorrow. Week 1 control plane checklist for Foundry agents. Let me turn this from architecture into something you can actually do in the first week. You don't need a program. You don't need a steering committee. You need a checklist that changes what is allowed to exist. Think of this as the minimum viable control plane for Foundry. Start with ownership. For every existing or proposed agent, there has to be a named owner. Not the AI team, not platform. A real team or function you can find in the org chart. Your first question is brutally simple. Who is accountable for this agent's behavior? If the answer is a person, you are brittle. People leave. If the answer is a vague group, you have no accountability. Pick a team and write it down somewhere security can see, then attach that ownership to identity. In week 1, define a pattern like this. All production agents use dedicated workload identities in Entra. Each of those identities is tagged with an owner team, a business purpose, an environment tag, and an expiry date. No tag, no production. You don't need perfect automation on day 1. You can enforce this with naming conventions, with tags, with a spreadsheet if you have to. What you cannot do is let the next agent ship under a generic automation account or a borrowed service principle because it's just a pilot. If you discover agents already running under those identities, put them on a remediation list immediately, not someday, now. Next, bring Purview into the conversation before anyone touches Foundry. You establish one champion rule, no label, no agent. Pick a minimal, opinionated label set you actually trust. Internal, confidential, highly confidential, regulated. Don't obsess over taxonomy purity. You can refine later. Declare in writing, only data with at least a baseline label is eligible for autonomous processing and only under explicit policy. Then define even roughly which labels agents can read and write in week 1. For example, agents may read internal and confidential. Agents may not read highly confidential or regulated without an exception process. Agents only write to destinations classified at least internal. You're not solving every edge case. You're drawing a bright line. Below this line, we experiment. Above this line, we don't. Now tie this to deployment. Whatever process leads to a Foundry deployment in your world, CI/CD, a ticket, a manual step in a portal, add 3 questions that must be answered before it succeeds. Does this agent use a dedicated workload identity with an owner tag? Do all declared data sources have purview sensitivity labels? Has someone asserted which labels this agent is allowed to read and write? If any answer is no, deployment stops. This can be as crude as a mandatory checklist on a change request. It can be enforced by a script that queries Entra and Purview. The mechanism doesn't matter in week 1. The non-negotiable part is that you remove plausible deniability. No one gets to say, and we didn't think about that, and then address observability. You won't build perfect tracing in 7 days. You can refuse to run blind. For every production agent, ask 3 more questions. Where do its traces live? What is the minimum set of facts we can reconstruct for each run? Who is responsible for looking at those traces when something goes wrong? If the answer to the first is, we don't trace this, that agent has no business in production. If the answer to the third is no one, assign ownership now, even if the answer is as crude as, the platform team owns all agent traces. Next, define exit. Every agent you allow into production needs a shutdown story. Write a single sentence per agent. This agent stops existing when X is true. X might be, this project ends, this product is retired, this queue is decommissioned, this owner team changes. Add one more line. When X happens, Y disables the identity and decommissions the agent definition. E is a real team, not somebody in IT. Finally, bake in a habit of hunting for the unknown. Run a basic inventory. List all Entra app registrations and service principals tagged for automation or AI. Cross-check with what you believe are your Foundry projects. Flag anything with no clear mapping to a current owner or business process. You won't fix it all in week 1. You're building a queue of agents and identities we don't understand yet. That queue is your early warning system for autonomous shadow IT. So your week 1 control plane checklist is this. No agent without a dedicated workload identity and an owner team. No unlabeled data in scope for autonomous access. No deployment without an explicit label policy for that agent. No production agent without at least minimal traces and a place to store them. No agent without a defined exit condition and a named shutdown actor. A standing task to hunt for identities and agents that sit outside those rules. You won't win awards for this. You won't inspire anybody. You'll do something more useful at this stage. You'll be the reason the first Foundry incident in your tenant is a near miss instead of the case study someone else presents at a conference with your name redacted and your architecture on every slide. Anticipating enterprise drift, shadow it, and regulatory pressure. Everything up to now has been inside one tenant and one platform. But enterprises don't drift one agent at a time. They drift as a system. So I want you to zoom out and look at the next 12 to 24 months of your estate through 2 lenses, next generation shadow IT and regulatory pressure that is going to land whether you are ready or not. Start with shadow IT, because that's where entropy always shows up first. Shadow it used to mean somebody swiping a credit card for SaaS, a rogue CRM, an unsanctioned file share, things that at least had a URL you could eventually discover. Shadow AI is the same pattern, just faster and harder to see. Teams can now spin up agents in multiple places. Foundry, Copilot Studio, third-party orchestrators, SaaS products that quietly added agent features to their enterprise tier. Each of those agents can be wired into your core systems through perfectly legitimate connectors: Graph, Dataverse, Exchange, ServiceNow, custom internal APIs. From a network and identity perspective, none of this looks obviously hostile. Tokens are issued, TLS is green, permissions were granted through the same consent flows you use for everything else. What you experience over time is not one catastrophic decision, it's decentralized AI risk. A sales org pilots an agent to enrich opportunities. Support builds their own triage agent in a different platform. Finance adopts a vendor-hosted reconciliation agent. Security experiments with an incident response agent. Every local team can justify their own move. None of them share a control plane. So when someone asks, how many agents do we have that can touch regulated customer data and under what policies? Your honest answer is, we know where some of them are. That's next generation shadow IT. Not just unknown apps, but unknown autonomous behaviors over known systems. Now layer regulation on top of that. Regulators don't care whether you call something an app, a bot, or an agent. They care what impact it has on real people. Most of the incoming AI requirements, whether you look at the EU AI Act, sector-specific guidance, or internal audit trends, converge on a few simple expectations. You know where AI is in your estate. You know what data it touches. You can explain how you decided it was allowed to do that. You can produce logs when something goes wrong. And for anything high risk, you can turn it off. High risk isn't a marketing label. It's anything that can affect someone's livelihood, credit, health, freedom, or access to services. That includes plenty of the agents your business is already dreaming about. If your Foundry adoption pattern is, we'll prototype first and wrap governance later, you're engineering the worst possible combination, decentralized AI risk with centralized accountability. Because when the letter arrives, from a regulator, from an internal audit committee, or from a customer's legal team, it will not be addressed to the team that hacked together the first agent. It will be addressed to whoever owns security, compliance, or the platform. This is where AI entropy becomes a governance problem, not just a technical one. Without a control plane, your estate tends toward opaque complexity, not because anyone is malicious, but because every local optimization, every quick agent adds another edge to a graph nobody is drawing. After a while, no one can answer basic questions. Which agents exist? Which identities do they use? Which labels can they touch? Who owns them? How do they die? And regulators are getting less interested in your intentions and more interested in your answers. 5 years from now, when people look back at Foundry versus Power Platform, they won't ask how quickly you enabled AI. They'll look at the first incidents and ask one thing: did you let autonomous execution into production before you had a way to see it, bound it, and prove you were in control? If the answer is yes, it won't matter that the tools were powerful or that your teams were moving fast. It will look like every other governance failure pattern in Microsoft history: SharePoint, Power Apps, Teams, just compressed into a shorter time frame, with agents instead of forms. And the first public Foundry-style incidents won't even be labeled correctly. They'll be called unexpected data access, AI misbehavior, configuration error. On paper, that will be true. On a risk register, it will be something else: governance arriving too late. The prediction, how this will officially fail. I want to end by telling you how this is actually going to look on paper when it finally breaks, because it won't show up in the incident report the way we've been talking about it here. Nobody's going to write, we allowed autonomous execution into production before we had a control plane. You're going to see 3 familiar phrases instead. Unexpected data access. AI produced an incorrect output. Configuration issue in an automation component. If regulators are involved, the language will tighten. The pattern won't change. On day 0, someone inside the business notices something that simply doesn't feel right. A summary email that includes HR details in a place where HR data has never appeared. A customer communication that references billing status no one thought the sender could see. A report that combines data from 2 systems that, on paper, are segregated. On day 1, security pulls logs. They do the obvious analysis. Was there an external attacker? Any sign-in anomalies? Any tokens from untrusted locations? Everything comes back clean. Every call came from trusted identities, through approved connectors, over encrypted channels. No sign of exfiltration, no brute force, no malware. The preliminary conclusion: no evidence of external compromise. On day 2, someone finally asks the right question. Could this have been an agent? They trace the path and discover that, yes, an agent, sometimes built in Foundry, sometimes living in a neighboring platform, was the one that assembled the output. It has a reassuring name: Assistant, Copilot, Triage Bot. On day 3, they pull the Entra object. They realize the identity behind that agent has broader permissions than anyone remembers granting, or that it's a shared automation account that has quietly accumulated rights over time, or that it's a workload identity with no current owner. Now the story shifts. This wasn't AI going rogue. This was a perfectly authenticated identity doing exactly what the platform allowed it to do. On day 4, they map the data. They see that multiple sources, each individually compliant, were combined in a way that violates policy intent. HR notes plus customer PII plus finance records merged into a single narrative, or internal risk ratings plus external credit data plus operational logs surfaced in a context that was never supposed to see all 3. At that point, the narrative is already being sanitized. The draft root cause statement will talk about a misapplied permission on an automation identity, an overly broad connector scope, a lack of testing of AI behavior in edge cases. There might be a sentence about insufficient guardrails or incomplete DLP coverage. You will see a remediation section that sounds mature. We will enhance governance for AI. We will improve monitoring of agent behavior. We will tighten access policies around automation accounts. We will provide additional training on configuration best practices. All of that will be true. None of it will be the actual cause. Because the real cause will be upstream. You allowed agents to execute in production before identity, data boundaries, and observability were treated as gates instead of after-the-fact annotations. You let the factory ship product before you finished building the breakers. Most organizations will frame this as a misconfiguration story because misconfiguration is comfortable. It sounds like an error, not a design. We misconfigured a permission implies the model was sound and a human slipped. What actually happened is that governance arrived too late by design. You will see that pattern replayed with minor variations. Sometimes the headline will emphasize AI hallucination, even when the hallucination happened entirely inside the boundaries you drew. Sometimes it will emphasize vendor behavior, even when the vendor only did what your identity and data model allowed. And here's the uncomfortable part. From the outside, 2 organizations will look very different after this wave. One will have a shorter, less painful set of incidents. They'll be held up in case studies as more mature, more responsible, ahead on AI governance. The other will spend years backfilling documentation, retrofitting policies, and explaining to regulators why an agent no one can fully describe was able to touch data nobody remembers approving. From the inside, the difference will be simple. The lucky orgs treated agents as production workloads on day 1. They enforced no owner, no execution, no label, no agent, no audit path, no production. The others told themselves a more optimistic story. We'll let teams experiment. We'll monitor and adjust. We'll add governance when we see what people actually build. They woke up to find that what people built had quietly become part of how the business operates, and taking it away hurt more than leaving it ungoverned. That's the shape of this failure when it finally lands. Not a dramatic AI catastrophe, a series of small, plausible incidents that all reduce, in hindsight, to the same decision. Execution was allowed before governance existed, and once you see it that way, the prediction writes itself. Most Foundry-related incidents will be officially classified as AI misconfiguration, unexpected data access, process gap in automation governance. But inside your own post-mortem, if you're honest, the line you'll write for yourself will be shorter. We let the factory run without a control plane, and it did exactly what factories do. The choice point. Foundry is not an AI feature, it is an agent factory. And factories without control planes don't produce value, they produce shadow IT. If you remember nothing else, remember this. If an agent can execute before identity, data boundary, and observability are in place, governance has already failed. Every agent you allow today defines the incident report you'll read tomorrow. You can decide now that no agent in your tenant runs without an owner, a labeled boundary, and an audit path. Or you can wait and learn those boundaries from an external report with your architecture on every slide. If you want more unapologetic failure analysis before it shows up in your inbox, stay with this series.